Hi, welcome to my bench. Here is a quick demo on testing the stepper motor controller using the PYNQ-Z2 FPGA board. Over here I have the PYNQ FPGA board hookup through PMOD to the ULN2003 Darlington array, and output of this goes out to the stepper motor. This is a bipolar type of stepper motor, and it has a total of 5 wires with VCC coming from center tap of both the coils. And to measure the waveforms of this, before that, this motor control sequence, it is coming through a Johnson counter which is implemented inside this FPGA fabric, and those alternating waveforms, which is a coil activation sequence for the stepper motor, uh, would come out of the PMOD, and this Darlington array actually helps in providing enough current for the motor to drive. Because yeah, we know, right, essentially the uh, GPIO or the pinouts of the PMOD are not capable of supplying like high currents as 500 milliamps. And then I'm using this RedPitaya stem lamp to hook up over to the jumper, and that would help me in looking at the waveforms which are used for the motor coils to rotate. So initially I had some issues in figuring out the functionality of the motor. It was not actually running, and only small vibration or buzzing noise was created, which later, after hooking up to a scope, I soon figured out it was an issue with the breadboard, which I had some wiggling connections. Sorry for those rusted old jumpers. And also it was because I was using 3.3 volt logic instead of 5, so that did help me in sorting out. And this is how handy a small bench oscilloscope with the size of palm would come to help in situation to sneak into circuits and debug it. Okay, anyways, you see the motor running over here, right? This is the coil sequence, and I agree it's not very beautiful though. Like, it ideally should have been a uh, nice little square waveform. But yeah, there are distortions which might be, I presume it's because I'm not using a very nice board wire up. It's just on a good old breadboard. So yeah, overall this is what the waveform looks like, and it's almost to a peak to peak of 5.5 volt, and the frequency is around 25 hertz. The other thing is, by using PYNQ overlay, we can always reconfigure the system. If we look at the Jupyter notebook window over here, I can run this command back to back and turn the motor right, left, or even stop it. So usually we would think while putting a design to FPGA fabric that would go fixed, but yeah, with by using overlay and the PYNQ utility, we can always on the fly configure the motor and control it. So yeah, that's it for the video. Thanks for hanging around.